Hi, my name is Emmanuel Tukudo, and I'm currently taking Physics 2212 at Georgia Tech, and this is my lab report on the charge tapes experiment. In this lab, we'll be looking at three key ideas. The first being Coulomb's law, which basically describes the electric force between two charged particles a certain distance apart with a certain charge H. The electric field is the force created by a charged particle. The electric field can be thought of as the force a small positive test charge will feel at a certain location due to a charged particle, and hence the units for the electric field are newtons per coulomb. The force due to gravity is an attractive force, and for the lab is simplified for use near the Earth's surface. The purpose of this lab was to understand the idea of charge, a property of matter, and to become familiar with the amount of excess charge on everyday objects. Also have here the formulas which I used on my computational model of code and the in-person lab, such as Coulomb's law and electric field due to a point charge, the relationship between the force and electric field, and the force due to gravity close to the Earth's surface. And here is a diagram of the setup of one of the experiments where we floated tape B by holding tape A below it, and also have my measured data from the lab such as the separation distance between the two tapes, as well as the mass, the length, and the width of tape B are all shown to the right. Now here's my computational model. As you can see, I've defined the function to calculate the charge on tape B by utilizing the Coulomb's law formula, and then I applied the formula for this lab, and specifically I also went ahead and set the force due to gravity equal to the negative of the electric force as they balance each other out. And basically that's what the calc charge formula does, as seen in the free body diagram to the right. Then I print out the relevant output, which we'll see in a bit. And lastly, I defined a very simple function to calculate the electric field using the formula from the previous page. So here's the output of my program. The orange arrow represents the electric force on tape A due to the other tape, and it's the one on top as it's the one we are interested in for this lab. I've also included the force of due to gravity in white, and you can also see the numerical output of the program to the right. So as you can see, the magnitude of charge as per the computational model is 1.857 times 10 to the negative 9 coulombs. And as you can see below, doing the same calculations by hand yielded the same results. I found my tip to be negatively charged as it was repelled by a negatively charged pen, which I obtained by rubbing it against 4. Based on lab experiments, the first assumption doesn't apply as tip B is static once it floats, so air resistance on a moving object is irrelevant to this lab. The second assumption does apply, as this is exactly what we did for both tape A and tape B to calculate the force between them and the electric field due to tape A on tape B. The third assumption also applies, as we assume that the charges on the two tapes were the same. We could reasonably assume this since the two tapes were charged in the exact same manner. Now for the what if and why questions. What if the electrons and protons had swapped charges? Simply put, this will have no effect on our observations, as this scenario playing out to be akin to a change in physics convention without any real impact on the world on our observations. And lastly, why do we take great care when handling charge tapes? Well, this has to do with the fact that with time, a charge tape comes into contact with a surface. If there are any excess electrons, they tend to escape, and if there is a deficiency of electrons, the new electrons from the surface tend to flow into the tape. Both of these situations will cause the tape to lose its charge, thus we handle them as little as possible so they retain as much charge as possible so that we could carry out this experiment properly. Thanks for watching.